Welcome everyone. Today is June 22nd. My name is Maciej, and I'll be your host for this batch working group meeting today. We have a couple of topics, but a quick announcement. Kubernetes AI HPC Day happening during KubeCon in Chicago from November 6th until 8th, if I remember correctly, or something along those lines. The call for proposal is open and it's due on August 6th. So you roughly have a month and a half to submit your proposals and sign up for the AI HPC Day if you're interested in attending. So that was the only announcement that I had, and now we can jump quickly to the first topic, and I have no idea who are we looking for. Lipovsek, not sure if L is the first name. Do we have a person to talk about the first topic? Hearing none. Okay, I'll move it to the next. In that case, Marcin, do you want to share your screen?
Actually, the presentation will be done by Daniel.
Okay. Yeah, and if you could kindly allow me to share screen, then I can start doing that. In the meantime, I can say, hi, my name is Daniel. I'm software engineer at Google, and yeah.
Hold on. Give me a second. Let me start sharing first, and then I should be able. Oh, Aldo, you're logged in as the other lead, or
sorry, say that again.
Are you or Abdullah logged in as the lead? Because apparently I can't make Daniel a co-host or be able to share his screen.
Is it me? Yeah, probably me.
Yeah, it might be. Based on what I'm seeing, that might be Abdullah. Can you make Daniel co-host so that he can share his screen?
Okay, seem to be able to share my screen.
Yep, we can see your screen.
But we can't hear you. You are muted.
Isn't that the problem where you're sharing the screen, you can't talk? I remember that they fixed that issue.
Okay. There is another button that was moved somewhere else. Okay.
Yeah, we can hear you.
Perfect. Today I would like to talk about the provisioning request CRD that I have EAP proposal in this link here, and yeah, that's the topic I want to cover today. So the motivation. Currently, cluster autoscaler does not provide a way for us to express fact that group of pods would like to have a capacity provision for them atomically before the pods are created. And there is a lot of situations this may be relevant for users. And a couple of them is that, for example, users might want to have all or nothing semantics for the scale up. And currently, due to like interactions between workload controller, be it like job controller or like other one, kube scheduler and cluster autoscaler, the VMs will be provisioned in a step function in a way. So like we will try to get some, then if we hit stock out or whatnot, or just because we don't see all of the pods, we will try to get more, and we will just go in the time before we get all of the VMs that we want. And because of that, like users will be paying for all of the time the VMs are there and are idle, basically, because they cannot proceed with their workloads without all of the VMs. And there is also like ETH latency for scale-ups. Some of the workloads may be bursting, and because of the same reason, users will expect bigger ETH latency, because each cluster autoscaler scale-up loop will just see some of the pods and just span a bunch of like have one request to cloud provider to create some VMs. And this latency will be like bounded by the slowest VM. And each of those, like usually we will have like, if we want to have 60 VMs, this will take not 6 times the request of getting 100 VMs. So there is some latency that we can cut off there. So this is my motivation for this, and we are proposing like an API which we call provisioning request CRD, which is custom resource object, and would be a namespace object where users can describe the group of the pods would be created and like that they want to have a capacity for them provisioned in a particular manner. And it should contain like the template of the pods and how many pods there are, and possibly different pod templates for different within a one provisioning request. So we can imagine like I want to have 10 jobs, like 10 pods that will be running a job, and one controller that will be just scheduling some specific tasks to them. And it should allow admins to like support different implementation of provisioning the capacity. So we can try to have atomic one. We can try to have like other modes of atomic. So maybe the step function, but make it configurable in a way that I'm happy with at least such and such VMs and whatnot. And this is an overview of how you would how the YAML of the one of the provisioning requests would look like. So you would have some name, some provisioning class, in this case like the atomic scale up, how long we can wait for the VMs to brought up, and like one pod set which would consist of 20 specific pods, each of them in this case like requesting 2.5 CPU and 1 GPU. And possibly there may be some other configuration that are relevant to the schedulability and whatnot. Yeah, any questions so far? Don't hear none. So here we had like generic atomic scale up, and within the EAP that I have, I'm proposing also a generic check capacity, which would basically be one of check to verify that the cluster, within a cluster, there is enough capacity to provision a given set of pods. This is not a real guarantee, like we will not block those this capacity for them. So like there will be nothing scheduled on down. But it may be useful in scenarios where we have only one workload admission controller, for example, the queue. In this scenario, we don't expect any like rogue pods to hijack this capacity. So if there is capacity, we can just assume in the queue loop that it's there after the check. Another one is the aforementioned the atomic scale up. And yeah, we want basically, as the name says, we want to have the capacity provision in an atomic manner. What this means in like the generic case, we will try to provision all required VMs in one cluster autoscaler loop. This may span, for example, different node groups, so different type of machines and whatnot. And if we succeed, then we pass this information to user. But if we fail, we move all of the partially provisioned VMs, remove them, and like retry some later in some exponential back of manner within this bounded duration that users can specify, as mentioned in the example. And what is also important, like users can provide a specific class for their, like cloud providers can provide specific classes. So for example, if one of the cloud providers was to have a better API to provision VMs in a way that we can go there and say, yeah, I want 100 of those VMs. If you can provision them atomically. If don't, just let me know. I will retry some later on. And this kind of logic will allow, for example, users to not pay for the partially provisioned VMs for the duration before we delete them. And yeah, the proposed lifecycle of the object is like as follows. So first, user or like a framework, for example, the queue, creates the object. Then like cluster autoscaler picks it up, chooses a node pool or one, and tries to create nodes. Or this is like, for example, the atomic scale up. So in this mode, we'll provision the nodes. In the check capacity, we'll just check whether it's there. And later on, we pass this information through conditions to users, whether we were successful or whether we are retrying or whether there is enough capacity or not. And at this moment, if for the atomic mode users, if we are successfully created the VMs, users can create pods. And users, they can mark those as with specific annotation that those are consuming the specific provisioning request. And like if all goes well, those pods should be scheduled on the dedicated capacity that was provisioned. And once all of the pods are scheduled, users can delete the provisioning request. Otherwise, it will be like garbage collected. Yeah, I have. I seem to be a question. Happy to answer it as of now. Abhishek?
Yeah, thanks for, sorry, can you hear me?
Yeah.
Yeah, thanks for presenting. So I had a question. So you made a comment that users don't pay for partial provisioned VMs. So can you describe that a little bit more?
Yeah. So one of the modes that we are saying is the generic atomic scale up, and in this mode, user pays for the partial provisions because this is like we try to get them the capacity, and if we cannot get the capacity fully, then different cloud providers may give us like only partial provisions, and in this one, users will pay for the capacity depending on the capacity, like the provider. But there may be like a specific cloud provider API to atomically scale up, and then this within this specific class, users may not be required to pay for this partial provision because those will not happen basically. Martin,
I see. So it's up to the cloud provider how they give you the resources or whatever the SLA is of that resource group. Got it.
Yeah. Like cloud providers may have different operation class, like and those may have different guarantees about the atomicity.
Okay, thank you.
Martin?
One comment here. So a little bit explanation how a cluster autoscaler is organized. So we have an interface for providing resources in cluster autoscaler that is implemented currently by about 30 cloud providers. We will add something new to the interface. However, it will take time before all of these 30 plus cloud providers respond and implement the API. Some of them may not have these capabilities available yet. So as a stopgap solution, we want to provide something like semi-atomic, like this generic scale up that gives you like some of the possible atomic experience, however, in a generic, not cloud-specific way. Some cloud providers may have something better already, and in that case, they will implement this API differently, like use some different ways to expand the number of nodes in the cluster. And then we will be able to provide better guarantees, stronger guarantees that once the provisioning request is started, it is actually fulfilled. And the impact, financial impacts for failed provisioned requests for the user is none or minimal. But that depends on the cloud providers, how they will respond. As Google, we want to integrate it with what we have on our end. So the idea is that soon there will be Google-specific implementation and generic semi-atomic implementation that should work for most of the cloud, and there will be interface for other cloud providers to follow so that they can use whatever secret API or public APIs they have on their own end.
Yeah, I think we have Alex next.
Hi, can you hear me?
Yeah.
Hey, thanks Daniel for presenting this. We actually have a few users who are interested in this type of gang scheduling, I guess you could call it. So very, very interested in this talk. Going forward to your next slide about the way it works, the fact that you have to submit this request, wait for the capacity, and then submit the pods. I'm wondering if there is a way maybe with a controller where you could specify the pods along with the provisioning request. And then once the capacity is available, you schedule those pods from removing that need to submit the pods and then remove the provisioning request, if that makes sense. Just to make the interface simpler.
Yeah, you mean like fire and forget mode, like you can create the pods and the provisioning request at the same time, kinda, and then just those should happen once the capacity is provisioned there. Like those should be scheduled once we have pods, like the node for them.
Yeah, I guess some abstraction here to say like, here's my real pod spec. Once the capacity is available for all of them together, put them, schedule them all together.
So that would be problematic because that would require additional step on scheduler. So right now in the picture, we've got only cluster autoscaler, which reacts to scheduling decisions, right? So you would like to have somehow block the pods, possibly with scheduling gates, and only unblock them once the provisioning request is there, right? Something like that. So that's possible. However, possibly as a responsibility of some additional controller. So that's not like rocket science. Probably won't happen in MVP. It's not for everyone, but yeah, it's something that could possibly be. It's something that could possibly be added to the proposal as like step number 2.
Great.
If I may answer the question from the queue perspective, this is one feature that we can easily integrate with from the queue controller. If you're not familiar, the queue controller does job scheduling, and it supports some APIs, in particular the job API. So if you use the job API, you submit a job, queue can create a provisioning request for you. Once the provisioning request is ready, queue admits the job and all the pods are created. That's one controller that will make use of this API, making it seamless for the researcher, let's say.
Yeah, that would be great if Q supported it.
Yeah, that is the plan. We want to have it as soon as possible, and we want to make this API kind of standard. So right now we as SIG Autoscaling working on with Carpenter folks on convergence plans between these two autoscalers, and the idea is that this API will not only be supported by cluster autoscaler but also by Carpenter. So hopefully it becomes a kind of standard way of asking for capacity in your cluster. And yeah, as Aldo said, we want to have it in queue as soon as possible.
I can also just quickly mention that this is also very interesting for the Armada projects where we have so similar needs. We sort of want to separately control resource provisioning and scheduling.
Okay, so please take a look at the proposal, and if you have any comments, drop them there.
I have a question related with the API, which is kind of related to what Alex was asking about. I'm looking at the provisioning request, and the thing that stands out is that I need to copy the entire pod spec from every other resource that I'm working with. Can we make the API a little bit more generic, such that we will either provide some kind of, for example, pod selectors, so that it knows what is the type of pod and it can read that pod from the cluster and get that information from the cluster, rather than me copying the entire pod spec from my job that I'll be creating, or if I'm going to be using it for a different resource type, then I don't know, maybe providing a reference to the type, and then, but that would, the downside, if we would go with the controller reference, we would have to read the actual pod from a pod template from the reference controller, which is doable for the built-in because you know roughly where to look for them, but it's a little bit more problematic with CRD. So maybe the pod selectors, so that you could save on those copy, and then eventually provide the pod spec as a fallback option if you cannot read that information off of a cluster anywhere.
So we thought about many possible use cases, including using pod templates that are also like a top-level object in Kubernetes and referencing them in the API. And that creates various types of problems, like these pod specs can be changed and they need to be monitored. If you want to monitor possible objects, like I know job deployment, then you expand the number of watches that are required to implement these features. So all of these things that you mentioned are possible, are not rocket science, but probably it would be better to do them after MVP and after initial launch, and see if there's like a real or strong need for them, because they will complicate the picture and implementation. And maybe people can live with copying the templates, and in that way make the life of API implementers a bit easier. But anyway, if you have strong feelings about that it should go other way around, please add them to the proposal.
Yeah, like I have a link at the beginning and at the end, so please comment and let me know what you think about it. With that, I think there's also a link in the agenda, so like
Daniel, one thing, the presentation slides that you shared, I tried and I cannot access. Can you share that with the back to work group mailing list alias? This way, all the participants
sure.
of the batch.
Daniel, please use your private Gmail our corporate policy prevents from
Okay.
allowing everyone to access the document. So if you do it from google.com account, you won't be able to properly share the document, or you'll be getting requests for reshares over and over.
Okay. I will quickly, like after the meeting, update the link in the docs.
Cool, thanks a lot. Do we have the person responsible for the other topic in the call? I don't hear anything. So I'll probably just bump this topic over to the next time. Does anyone else have any other discussion points that they want to bring up with the group? Okay, hearing none. With that, I'm going to give you back about 15 minutes of your time. Thank you very much for today and see you next time. Bye all.
Thanks.
Bye-bye.
Bye.